Hello there and welcome to today's class. For today's class, we'll be dealing on the concept behind basic rules in naming organic compound. So how do you name organic compound? Last class, we discussed about the introduction of organic chemistry, definition, and we discussed about some basic technologies such as the homologous series, the alkyl group, the functional group, the what's it called, saturated and unsaturated hydrocarbon. We discussed about sigma and pi bond and what have you. Also we discussed about hybridization. So those are like what we discussed last class under the introduction of organic chemistry. So as a beginner or as a fresh student that doesn't have any idea of organic chemistry, you can simply watch our first class on organic chemistry to get used to how it works. And also, if you are an expert before but trying to remember the concept behind organic chemistry, our video is readily available for you. So watch our first class on organic chemistry using the link you see above you here, or check the description of this video. You see the link there to our first class. For this class, we're considering how to name organic compound. So we're looking at some basic rules in naming organic compound. Before we dive into basic rules in naming organic compound, let's discuss about these two example here. Last class we discussed about something very important called sigma and pi bonds. So for this question here, we are told to find the total number of sigma bonds and total number of pi bonds, and also tell the hybridization pattern of the highlighted carbon compound. So what we know before is that for alkane, that's sp cube hybridized, alkene are sp squared hybridized, and alkyne are sp hybridized. So tell the hybridization pattern of the highlighted carbon compound here. All right, my first task now is that let's get the total number of sigma bonds and pi bonds here. We said when it comes to sigma bond occur in what? In single bond, while pi bond occur in both double bond and triple bond. So for this triple bond here, we said for one triple bond, I have one sigma bond and two pi bond. This is a triple bond. A triple bond contains one sigma and two pi bonds. So let's count the number of sigma bonds here. This is 1, 2, 3, 4, 5, 6, 7. With this one here, 8. So I have 8 sigma bond here. 8 sigma bonds. So let's get total number of pi bond. We said pi bond occur majorly pi bond occur majorly in what? In double bond and triple bond. So I'm seeing a triple bond here. So I'm having 2 pi bond. So for this organic compound here, I'm having just only what? 2 pi bonds. All right, at this point here now, I haven't gotten the sigma bond and top pi bond. We are told to find the hybridization pattern of the highlighted carbon compound. This carbon here, this is the what's it called, functional group here. This is the highlighted carbon compound here. So for triple bond, what's the hybridization pattern? Triple bond is called alkyl. So alkyl, so this is what? sp hybridization. So this carbon compound here is what? sp hybridization or sp hybridized. Why? Because the alkyl triple bond. We said alkane are sp cube hybridized, alkene are sp squared, while alkyl, which are triple bond, are what? sp hybridization. Let's get the total number of sigma bonds here and total number of pi bond. For this one here, my first task is that I'm seeing double bond. A double bond contains one sigma bond and one pi bond. So I'm having one sigma bond, one pi bond. So let's get the number of sigma bond here. For sigma bond, I'm having 1, 2, 3, 4, right? So 5, 6, 7. So for this organic compound here, I'm having 7 sigma bonds. At this point now, let's get the number of pi bond. pi bond occur majorly in what? Double bond and triple bond. So I'm saying double bond here, I'm just having one pi bond. So for this organic compound here, I'm having just one pi bond. Let's get the hybridization pattern. This is a double bond, of course. This is another carbon compound. This is a double bond. A double bond is simply what? The sp squared hybridization. Sp squared hybridization, right? Because it's a double bond, and double bond is what? Alkene. That's sp squared hybridization. All right, having understand this concept now, let's dive into the basic rules in naming organic compound. So what are some of the rules needed in the concept of naming organic compounds? Let's consider some of the rules important in naming organic compound. So let's start with rule 1. So rule 1 says that, let's start with the all right. When it comes to basic rules in naming organic compound, there are about 6 distinct rules in naming organic compound. For this class, we're looking at just three rules that guide the concept of naming organic compound. In our next class, we'll discuss about the other 3 rules. So for this class, let's start with the rule 1 in the rule 1 of naming organic compound. Rule 1 says select the longest continuous carbon chain, has the root hydrocarbon, and count the number of carbon atoms in the organic compound and give it this pattern of naming. If it contains 1 carbon atom, call it met. 2 carbon atom, call it et. 3, call it pro. 4, call it but. 5, call it pent. 6, call it x. 7, call it ept. 8, opt. 9, non. 10, deck. 11, on deck. 12, do deck. 13, try deck. So it means that I'm saying that rule 1 says that select the longest continuous carbon chain, has the root hydrocarbon, and count the number of carbon atoms it contains and give a pattern of naming. If I have an organic compound, my task there is what? Count how many carbon atom is there, how many carbon is there. So if it is that in the organic compound I'm just having 1 carbon atom, you call it what? Call it met. 2 carbon atom, call it et. 3, pro. 4, but. 5, pent. 6, x. 7, ept. 8, ox. 9, non. 10, deck. 11, on deck. Do deck and try deck. So this is the concept behind rule 1 of naming organic compound. Rule 2 says that identify the functional group. That's the rule 2 that guides the concept of naming organic compound. Identify the functional group. If it's an alkane, a single bond, alkene, double bond, and alkyl, triple bond, OH, alkanol or alcohol. So if I'm seeing a single bond, that's an alkane, a double bond, alkene, a triple bond, alkyl, OH, that's alkanol or alcohol. So let's use rule 1 and rule 2 to name few compounds. If I have a compound such as this, let's balance this one up. 1, 2, 3, 4. Balanced. Let's name this compound. What do you call this? If you're familiar with our last class, when we did introduction to organic chemistry, I gave you the name for this one, right? This is the first member of the alkane, CH4, right? So what do you call this? How do you name this? We said rule 1 says count the number of carbon atom. For this one, I'm just having 1 carbon atom. You say for 1 carbon atom, what do you call it? Call it met. So rule 1 says call it met. That's rule 1. Call it met. What's rule 2? Rule 2 says identify the functional group. I'm seeing a single bond. A single bond represents what? Alkane. So I'm having what? Alkane as a single bond. So to name this compound now, I'm having met. So I'll not write alkane. I just write what? The last ane. ane. So this is called what? Methyl. So CH4 is called methyl, as you can see. Let's use row 1 and row 2 to name other compounds. Let's say I have a compound such as this. Let's balance this. This is 4. Balance 1, 2, 3, 4. Balanced. Let's name this compound. How do you name this? To name this compound here, it's quite simple. What's the first task? We said our first task what? Count the number of carbon atom, right? Or yes, the longest continuous carbon chain, right? And count the number of carbon atom. So I'm having 2 carbon atom. 2 carbon atom. Call it what? Call it 8. So I have 8. 2 carbon atom. Root 2 says identify functional group here. What's the functional group here? Of course, I'm seeing a single bond, but aside single bond, I'm seeing OH. So there's a kind of functional group that represents OH. That's what the alkanol. So that's alkanol. Alkanol, right? So to name this compound now, I'll be having 8. Then I'll write the last ANOL. Anol. So this compound is called ethanol, as you can see. So this compound is called ethanol. All right, let's consider the third rule in naming organic compound, and we look at how to use row 1, row 2, and row 3 to name several other compounds. All right, let's consider the rule 3 that governs the concept of naming organic compound. Rule 3 says that number the number of carbon atom from the root hydrocarbon, which will give the least or lowest possible number to the substituent in the hydrocarbon or organic compound. So when it comes to rule 3, the idea is what? Do your numbering. So when it comes to the 3, we have what we call the upper numbering and lower numbering. And aside from that, there's what we call substituent. So rule 3 explain the concept behind substituent. What is substituent? A substituent is simply an organic compound or inorganic compound. By organic compound, I mean ethyl, methyl, propyl, butyl, etc. And the concept of inorganic compound, I mean the halogen like bromine, chlorine, fluorine, iodine. So I'm saying that when it comes to the 3, the idea is that you look for a least or lowest possible number to a substituent, right? To a substituent. So the idea is quite simple. If you're given an organic compound such that, so the concept behind rule 3 is quite simple. Just your task when it comes to the 3 is to figure out the substituent in the organic compound and make sure that you give the substituent the least or lowest possible number, right? So let's take a few compounds to explain the concept using the idea of row 1, row 2, and row 3. Let's say I have a compound such as this, right? 1, 2, 3, 4, balanced. This 1, 2, 3, 4, balanced. 1, 2, 3, balanced. 4, 1, 2, 3, 4, balanced. 1, 2, 3, 4, balanced. Let's say we are told to name this organic compound. How do you name this one? Let's start with row 1. What do we know from row 1? Row 1 says select the longest continuous carbon chain. The longest, I'll pick the longest. Look at this now. Let's count the longest continuous carbon chain. And also, after getting the longest carbon chain, we count the number of carbon atoms it contains. For this one now, I have 1, 2, 3, 4. Like this is 4. 1, 2, 3, 4. Going like this is 4. Do not count like this. 1, 2, 3, 4, 5. This is wrong. There is not a linkage between this carbon and this carbon. So I can't count 1, 2, 3, 4, 5. It's wrong. How do you count 1, 2, 3, 4? Why? Because there's a linkage between them, or 1, 2, 3, 4. There's a linkage between this carbon and this carbon. This is a linkage here between them. So it means that either I go like this or I go like this. I'm still having 4. But the rule says select the longest one. So I'm not having longest one. I'm having 4, 4. Either I choose to go like this or like this. It's still correct. So I'm going like this. I'm choosing to go like this. Let's say I want to go like this. For instance, I'm going like this now. We said rule 1 says select the longest continuous carbon chain as the root of the carbon and count the number of carbon atoms contained. I have 1, 2, 3, 4. 4 carbon atoms. What do you call 4 carbon atoms? Call it boot. We call it boot. What's root 2? Root 2 says identify the functional group. This is single bond. It's represented by the alkane. So I have what? Alkane as my second consideration here. We said root 3. What's the concept behind root 3? Root 3 says what? Our task in the concept of root 3 is to figure out substituent. Of course, this one is a substituent. Why? Because it's not part of the root hydrocarbon. So look like a substituent. So when it comes to root 3, there is what? Do your numbering such that you have the least or lowest possible number to substituent. Alright, if I do my upper numbering, I have, this is carbon 1, 2, 3, 4. Using upper numbering. Let's use lower numbering. I'll have carbon 1, 2, 3, 4. This is my substituent here. This substituent is attached to carbon 3 using my upper numbering. This substituent here is attached to carbon 2 using my what? Lower numbering. In between 3 and 2, which one is the least? Of course, 2 is the least. So it means that to name the organic compound that are having a substituent, name the substituent first and show the position of the substituent. So I'm having 2. This is 2 what? This is, we call this, what is this called? This is CH3. This is CH3, right? This one is called CH3. This is C and 3 hydrogen. In our last class, when we discussed about the alkyl group, the first member of the alkyl group is CH3. What do we call it? We call it ethyl, right? So we're saying that to name organic compound that have a substituent, name the substituent. To name organic compound that's having a substituent, name what? Name the substituent first by showing the position. So I'm having this substituent here falls at position 2. That becomes 2 what? What substituent? Ethyl. 2-ethyl. This is called 2-ethyl. Next up, the functional group here. That's butane. ANE, butane. So this compound is called 2-ethyl butane. This compound is called 2-ethyl butane. Let's name other compounds. Example 2. Let's say I have a compound such as this. 1, 2, 3, 4. Balanced. 1, 2, 3, 4. Balance. 1, 2, 3, 4. Balance. 1, 2, 3, 4. Balance. Let's name this compound here. How do you name this? We said rule 1 says select the longest continuous carbon chain. Of course, this is the longest here, so I have this one as my longest continuous carbon chain. Let's count this. 1, 2, 3, 4. This is 4, and 4 is boot. Rule 2 says identify the functional group. This is what? A single bond. That's alkane. I have alkane as single bond. What's rule 3? Rule 3 says what? Rule 3 gives the idea of what? Substituent. So this is a substituent here, bromine, a substituent. So I'll look for the least possible number to substituent. Using my upper numbering, I have 1, 2, 3, 4. Upper numbering. Lower numbering, I have 1, 2, 3, 4. I will pick the least number substituent. In between upper numbering and lower numbering, Which one gives the least number to substituents? Bromine. That's what? Lower numbering. So I'll discard what? The upper numbering and go with what? Lower numbering. Does not mean that it's always up or lower numbering that works all through. Look at this one now. Lower numbering works here. Look at this one. Lower numbering works here. Does not mean that every organic compound goes with lower numbering. No. In some cases, it might be what? Upper numbering. So for this one now, I'm having two bromine here. We said name the substituent first. I'm having two and show the position. That becomes two bromo. You call bromine, call it bromo. So I have two bromo. Next up, butane becomes butane. This compound is called 2-bromobutane. This one is called 2-bromobutane. Let's take one last organic compound and let's see how we can work them out. So let's say I have a compound such as this. All right. Balanced. Let's name this compound here. Balanced. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Balanced. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Balanced. Let's name this organic compound here. How do you name this one? We said rule 1 says select the longest continuous carbon chain. This is 1, 2, 3, 4, 5, 6, 7, 8. Like this is 8. Let's use let's count straightforward. Let's see 1, 2, 3, 4, 5, 6, 7, 8. Straightforward 2 is 8. Okay. Let me eliminate this one. So let's use this one. Let's use this one. I want to show you something. So this is 1, 2, 3, 4, 5, 6, 7. Like this is 7. 1, 2, 3, 4, 5, 6, 7, 8. Like this is 8. In between 7 and 8, which is the longest? Of course, 8. This becomes the longest continuous carbon chain. That's 8. 8 is called rule 1. 8 is called oct, as we know. Rule 2 says identify the functional group. This is a single bond. That's what? Alkane. Alkane for representing single bond. 1 rule 3. Observe a substituent. This is my substituent. Why? Because it's not part of the root hydrocarbon. So this becomes CH3, which is what? Ethyl, as we know. Ethyl. So how do we name this compound? We said rule 3 says what? Look for the least possible number of substituents. This substituent here. Let's go to the upper numbering. This is 1, 2, 3, 4, 5, 6, 7, 8. Lower numbering 1, 2, 3, 4, 5, 6, 7, 8. In between upper numbering 6 and lower numbering 3, which one is the least? Of course, the lower numbering. So I'll discard or perhaps eliminate my upper numbering. So I will go with what? The lower numbering. From my lower numbering, which is 2, which is 3, attached to the carbon. 3. So that becomes, this becomes 3 what? One substituent, ethyl. 3 ethyl. 3 ethyl. Then the functional group there, octane. Alkane, octane. So this compound is called 3-ethyl octane. Next class, we look at the next 3 rules that governs the concept of naming organic compound. Do well to subscribe to my channel, like and share the videos, and leave a comment in the comment section below. And also do it to invite your friends and classmates to our YouTube channel. Don't forget to subscribe and hit the notification button so you be notified when we drop a new content on organic chemistry. See you in the next class.